Good morning. This is a lesson for November 30th, and it's for undefined fractions. Okay, so remember, first of all, remember a fraction is undefined if and only if the denominator equals 0. Okay, a fraction is undefined if and only if the denominator equals 0. Okay, so what you need to be able to do is to think of this in terms of functions. So here's a fact. A rational function, and remember, a rational function is really just a fraction, like a fraction of polynomials. So if it's a rational function like p of x over q of x or something like that, that's a rational function, right? Where p and q are both polynomials. So a rational function is undefined if and only if q of x equals 0. That's the denominator, right? So if they gave you a fraction, a rational function, like for example, suppose they said something like, here's a rational function, x squared minus 36 over 8x minus or plus 24, let's say. Okay, and they said for what values of x, or which values of x, if any, for which values of x are, is or are, I don't know, are the fraction undefined. Is, or I don't know if that's right. Whatever. Okay, so if you have a rational function like this, and you want to know for what values of x make it undefined, you would just set the denominator equal to 0. That's it. So this would just be 8x plus 24 equals 0, 8x equals negative 24, and x equals negative 3. That would be it. That's the only x value that you can't substitute in here and have this make sense. All right, there's definitely points where the numerator equals 0, right? It's 0 at 6 and it's 0 at negative 6, but those aren't going to be values that make the denominator 0. They're only values that make the numerator 0. And if you have a fraction where the top is 0, but the bottom's not, like at 6 and negative 6 in this case, the answer is 0. Like you could plug 6 in and you get 0. You could plug negative 6 in and you get 0. But you definitely can't plug negative 3 in. So that's the only value that makes this fraction undefined. Okay? That's all there is to this stuff. So like, for example, suppose the fraction was different. Like suppose, get a different marker here. Suppose the fraction was y equals x squared minus 1 over x squared minus 16. Same question. If they asked you where this is undefined, you would just say x squared minus 16 equals 0. This factors x minus 4x plus 4. So x equals 4 and negative 4. Those are the two values of x that make this fraction undefined. Okay. It's possible the factoring might be like a little bit different. Like what if I have something like the fraction 6x minus 54 over x squared minus x minus 30. Same deal. I would just say x squared minus x minus 30 equals 0. This factors x minus 6x plus 5. So x equals 6 or negative 5. Those are the two values of x that make that fraction undefined. This is pretty easy, isn't it? One more example. How about something like 2x plus 8 over x cubed plus 7x squared plus 10x. Same thing. I would set the denominator equal to 0. So this would be x cubed plus 7x squared plus 10x equals 0. I could take out a common factor. There's an x in all three terms. X squared plus 7x plus 10. Now it's just a normal quadratic trinomial here. So this would be x plus 5, x plus 2. So in this case, I get three numbers that give me an undefined fraction. I get 0, negative 5, and negative 2. All right, so that's all you're going to do in these problems. They're going to give you a fraction of polynomials, and they're going to ask you what values of x make that fraction undefined. So you're just going to set the denominator equal to 0 and solve. Okay? I hope this helps, and enjoy your day. See you tomorrow.